girls. Now we are in our unit 3 and it is trigonometry, the most important and interesting concept in mathematics. Okay. So let's recall few basic results. You know what is an angle and the types of angles such as complementary angle, supplementary angle, everything you have learnt it already. Okay. So now directly we are going into the concept of quadrants. So this system is divided into 4 quadrants. It is the first quadrant and it measures the angles from 0 to 90 degree, and it is second quadrant and it measures the angles from 90 degree to 180 degree. In the third quadrant it ranges from 180 degree to 270 degree. In the fourth quadrant it ranges from 270 degree to 360 degree. It is 0 degree as well as 360 degree also. Here I draw an angle that approximately measures 35 degree. In this angle, this side, the initial side lies on the x-axis. It coincides with the x-axis, the positive side of x-axis. If for any angle, if it coincides, if it lies along the x-axis, then we call this angle is in standard position. Then we can tell that that particular angle is in standard position. It may be vary, any angles you can draw, but if the initial side of the angle lies along the positive x-axis, we can tell that the angle is in standard position. So we have to measure the angles in the anti-clockwise direction, not in the clockwise direction. So it is in the anti-clockwise direction, it is 35 degree. Likewise, in the anti-clockwise direction only we used to draw or measure angles. If I come in the clockwise direction, if I come along this direction in the clockwise direction, then my angle will become negative. Okay. I start from 0, if I come to this position, then it is minus 90 degree. So 270 is also known as minus 90 degree because I measured the angle in the clockwise direction. So I start from 0 and I took one complete rotation in the anti-clockwise direction and it will result in 360 degree. After one complete rotation, it measures 360 degree starting from 0. Okay, so we can measure angles larger than 360 degree also. So angles after 360 degree, for example, angle 400 and 400, angle 400 degree. Okay, so it is approximately comes here. Okay, so after 360 degree, I have to measure 40 more degrees in the anti-clockwise direction to draw this angle 400 degree. Okay, so one complete rotation mudicha paragum anti-clockwise direction it will go on. So it will take, for one complete rotation it took 360 degree, for two complete rotations it took 720 degree, likewise it will go on. Okay, so these angles 0 degree, 360 degree, 720 degree, okay, are all called as coterminal angles. Similarly here angle 40 degree will come here. Okay, 40 degree will come here, and in one complete rotation 400 degree also comes in the same position, and after two complete rotations 720 plus 40, what it is? 760 also comes in the same position. So in this position these are all the coterminal angles. Okay, I hope you can understand. So we can mark any angles, any measures. Similarly, if I come like this is our minus 90 degree, as I said. Okay, so this minus 90 degree and 270 are also coterminal angles because they occur in the same position. Okay, so if I come like this, it is our 180 degree. If I come like this, it is a minus 180 degree. So 180 and minus 180 also coterminal angles. In trigonometry, we used to learn more about triangles. Okay, in that case, it usually deals with the right triangle. So many cases. Okay, so as usual, the 6 ratios you can know the 3 sides and 3 angles. Okay, the trigonometric ratios are also okay. Sin theta is equal to opposite side by hypotenuse, and cos theta is equal to adjacent side by hypotenuse. And tan theta is equal to opposite side by adjacent side. Okay, and these are all the relations and the ratios. Okay, also you have to recall and you should be well versed about this also. Okay, so these 3 identities also you have learnt that, and these 3 basic identities, these are all known as Pythagorean identities, the fundamental identities. Okay, cos square theta plus sin square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta is also equal to 1. These are all the fundamental identities, and we will use these identities in while solving the exercise problems. Okay. Identify the quadrant of the following angles. So we have to find in which quadrant the particular angle lies. So 78 degree, 78, you can tell it is in the first quadrant. Easily you will tell that. So 78 degree, it lies in the first quadrant. Yeah, okay. So 0 between the angle theta and 90 degree. 0 less than or equal to theta, less than or equal to 90. It is in the first quadrant. Okay. So 78 you will tell easily. What about less than only, not equal to. Okay. So what about 900 degree? 900 degree, it will take multiple rotations. Not only you can measure 900 degree in a single rotation, it will take multiple rotation. How will you find it? So for that you can divide the 900 with 360. For one complete rotation it takes 360. So you have to divide the angle measure of the angle with 360 degree. So how many times? It will take approximately 2. So 2 times 360 is 720. So while subtracting here 10, so 8 and 1, 180. So the remaining, it is 180 degree. So it lies on the x axis. Okay. In case this angle 900 degree lies on the x axis, we couldn't tell the quadrant for this. Okay. If this angle is 905, what will happen? If it is 905 degree, then 905 similarly 2 times 720, so 5 will come here, 185. 185. So from this 0, 90, 180, so 185 will come here. So it is in the third quadrant. Here it is in the first quadrant. Minus 40, we have to come in the clockwise direction. So minus 40 lies in the which quadrant? Fourth quadrant. 250 degree. So 250 means in this quadrant only, third quadrant only, the angles measures lies between 180 and 270. So 250 will come here in the third quadrant. Minus 250. So if I start from here in the clockwise direction, so minus 90, minus 180 and minus 250 will come in this quadrant, and it is second quadrant. And the last one, it is 526. To measure this, what we have to do? We have to divide the higher measure by 360. So 1 time 360. So 6, 52. It is 166. Where this angle will lies? It comes in between 90 and 180. So 526 lies in the second quadrant. Likewise, we have to Find the quadrant. For each given angle, find the coterminal angle with measure of theta such that 0 degree less than or equal to theta less than 360 degree. We have to find the coterminal angle. That angle lies on the same place. Okay. So, we have to find the coterminal angle for these given angles. Okay. So, first 400 degree. இது coterminal angle ஒரு rotation வந்த பிறகும் அதே placeல வருது அப்படின்னு சொன்னா those angles are known as coterminal angles. Okay. So 400 degree. 400 degree. How could you find this? So 400, it is very simple. So from 0 if you start, after one full rotation it will come to 360 and then after 40 measures degrees you will get 400. So 440. 440 are the coterminal angles. If they give some different values, how will you find it? So you have to divide 400 by 360. So 1 times 360 and the remainder is 40. So 40 is the coterminal angle. So it is a negative angle, minus 270. So you have to come in the clockwise direction. From 0, it is 90 degree, 180 degree and 270 degree. So minus 270 lies on the place, on the same place where we will measure the angle 90 degree. So minus 270 and 90 degree are the coterminal angles. Here it is minus 510. So minus 510. So you have to write 500 and minus 510 in terms of 360. So minus 360 again minus 150. Okay, so minus 360 and minus 150 will give 510, isn't it? So 0, 0, while you adding you will get 0, 6 and 5, 11. So 1, 3 plus 1, 4 plus 1, 5. So I can rewrite 500 and minus 510 as minus 360 minus 150. So the coterminal angle is 150 degree. What about this 1080 degree? So similarly you have to divide this 1080 with 360 degree. So 3 times it will go. So 0, 6 3s are 18, 3 3s are 9 plus 1 10. Okay. So you will get the remainder as 0. So what is the coterminal angle? It is 0 degree is the coterminal. What about 625? Similarly, you have to divide like this 625 with 360. So 1 times it is 360. So 5, again 6, here 2. So 625 and 265 degree are the coterminal angles. If A cos theta minus B sin theta is equal to C, show that A sin theta plus B cos theta is equal to plus or minus square root of A square plus B square minus C square. This is the third sum in first exercise, exercise 3.1. Okay. It is given that A cos theta minus B sin theta is equal to C. So we have to square. On squaring both sides, we get A cos theta minus B sin theta the whole square is equal to C square. It is in the form A minus B the whole square in that identity. Okay. So how will you expand that? A square plus B square minus 2AB. So in the place of A, we have A cos theta. So it is A square cos square theta. In the place of B, we have B sin theta. So plus B square sin square theta minus 2AB. So minus 2AB cos theta sin theta in the form A minus B the whole square. In that using that identity, we are expanding it here. It is equal to C square. Okay. So now I am writing using the identity sin square theta plus cos square theta is equal to 1. I write cos square theta as 1 minus sin square theta. Similarly, sin square theta as 1 minus cos square theta. So, cos square theta as 1 minus sin square theta and sin square theta as 1 minus cos square theta minus 2ab cos theta sin theta is equal to c square. Now, I multiply this inside. So, a square into 1 it is a square minus a square sin square theta plus b square into 1 it is b plus b square minus b square cos square theta minus 2ab cos theta sin theta is equal to c square. Now, I bring the c square here, the constant a square, b square and c square on one side and other elements to the opposite side. So, a square plus b square, and while c square coming here, the sign will change, so it is minus c square is equal to, so while minus a square sin square theta going to the opposite side, it will become a square sin square theta plus b square cos square theta plus 2ab cos theta sin theta. Okay, so a square plus b square minus c square is equal to, this is in the form a plus b the whole square, a square plus b square plus 2ab. So, I can write it as a sin theta plus b cos theta the whole square, a plus b the whole square. Okay, what do we need to prove? A sin theta plus b cos theta is equal to plus or minus square root of a square plus b square minus c square. So, here a sin theta plus b cos theta the whole square is equal to a square plus b square minus c square. So, while taking the square root, it will become, shall we exchange, a sin theta plus b cos theta the whole square is equal to a square plus b square minus c square while interchanging. Okay, so taking square root, on both sides, you get a sin theta plus b cos theta is equal to square root of a square plus b square minus c square. It is plus or minus. This is what we have to prove, and hence we proved. Fourth problem, if sin theta plus cos theta is equal to m, show that cos per 6 theta plus sin per 6 theta is equal to 4 minus 3 into m square minus 1 the whole square divided by 4, where m square is less than or equal to 2. So, what is given? Sin theta plus cos theta equal to m, and it is given. Okay. So, left hand side cos per 6 theta, first we will take the left hand side and derive it as an expression, and then we will take the right hand side and derive it as another expression and check whether both are equal. So, LHS cos per 6 theta plus sin per 6 theta. I write cos per 6 theta as cos square theta the whole cube, sin per 6 theta as sin square theta the whole cube. Okay. So, square theta ku cube edukrom, 3 2s are 6. Now, I write this as, okay, it is a cube plus b cube. What is a cube plus b cube? A cube plus b cube is equal to a plus b into a square plus b square minus ab. It is an identity, right? So, I use this identity here, a cube plus b cube is equal to a plus b into a square plus b square minus ab, and rewrite it as cos square theta plus sin square theta. I take cos square theta as a and sin square theta as b here, right? So, cos square theta plus sin square theta, that is a plus b, into cos per 4 theta, that is a square, sin per 4 theta b square minus ab. What is cos square theta plus sin square theta? It is 1. And cos per 4 theta, I will write the remaining expression here as cos per 4 theta as cos square theta the whole square, sin per 4 theta as sin square theta the whole square minus cos square theta sin square theta. Okay, so இப்போ இது cos square theta the whole square plus sin square theta the whole square. Here it is in the form a square plus b square. புரியுதா? இது 1, இது வந்து cos square theta plus sin square theta equal to 1 ஆயிடுச்சு. இந்த எக்ஸ்பிரஷன் மட்டும் இருக்கு. இந்த எக்ஸ்பிரஷனில் இருக்கிற இந்த ஃபர்ஸ்ட் 2 terms cos power 4 theta sin power 4 theta-வை cos square theta the whole square sin square theta the whole square-னு எழுதியிருக்கேன். இந்த term அப்படியே இருக்கு minus cos square theta sin square theta. Here we are using another identity. What it is? It is a square plus b square. So, a square plus b square is equal to a plus b the whole square minus 2ab. Okay, so a plus b the whole square is equal to a square plus b square plus 2ab. So, அதை மாற்றி எழுதும்போது a square plus b square is equal to a plus b the whole square minus 2ab. இதுதான் நமக்கு a square, இது b square. Okay, so a plus b the whole square, that is cos square theta plus sin square theta the whole square minus 2 into ab. 2ab na enadhu minus 2 into cos square theta sin square theta. So for this term I have expanded it here and minus cos square theta sin square theta இங்க அப்படியே இருக்குது. இந்த minus cos square theta minus sin square theta இங்க அப்படியே இருக்கு. So cos square theta plus sin square theta is equal to 1. So 1 square, it is again 1. இங்க minus 2 cos square theta sin square theta minus cos square theta sin square theta இருக்குது. So இது 2 times, இது 1 time இல்லையா? So ரெண்டு add பண்ணும்போது it is minus 3 cos square theta sin square theta. So while deriving the left hand side expression we get 1 minus 3 cos square theta sin square theta. Mark it as 1. Now take our RHS. 4 minus 3 m square minus 1 the whole square divided by 4. Okay, so 4 minus 3 into m square minus 1 the whole square divided by 4. In the m square minus 1 whole square, I have solved it here. Okay, so m square minus 1 the whole square is equal to, or m is equal to sin theta plus cos theta. So sin theta plus cos theta the whole square minus 1 the whole square. Here it is a plus b the whole square. So a plus b the whole square, a square plus b square plus 2ab. Minus 1 இருக்குது. Okay, இந்த minus 1 இங்க இருக்குது. Okay, so sin square theta plus cos square theta is equal to 1. This term 2 sin theta cos theta இதில் இருக்குது minus 1. 1 minus 1 it will become 0. So 2 sin theta cos theta the whole square. Only left out. So it will become 4 sin square theta cos square theta. So m square minus 1 the whole square can be replaced by 4 sin square theta cos square theta. That's what we have done here. Instead of this m square minus 1 the whole square, I have written 4 sin square theta cos square theta divided by 4. Okay, so 4 by 4 minus 3 4 sin square theta cos square theta divided by 4. 4 and 4 get cancelled here, here as well 4 and 4. So it is 1 minus 3 sin square theta cos square theta and it is a 2. See, our 1 is 1 minus 3 cos square theta sin square theta. Here as well, while solving the right hand side also you get the same expression. So from 1 and 2, left hand side is equal to right hand side and hence we have proved. If cos power 4 alpha divided by cos square beta plus sin power 4 alpha divided by sin square beta is equal to 1, prove that sin power 4 alpha plus sin power 4 beta is equal to 2 sin square alpha sin square beta. And second one, cos square beta divided by cos square alpha plus sin power 4 beta divided by sin square alpha is equal to 1. So first we'll take this, the given equation, cos power 4 alpha by cos square beta plus sin power 4 alpha divided by sin square beta is equal to 1. So now in the next step, cos power 4 alpha divided by cos square beta is equal to 1 minus sin power 4 alpha divided by sin square theta. I am bringing this term along to the opposite side. Now take LCM sin square beta. So it is sin square beta minus sin power 4 alpha. Here cos power 4 alpha divided by cos square beta. Now we can cross multiply it. So while multiplying this 2 and this 2, okay, so you get cos power 4 alpha sin square beta is equal to sin square beta minus sin square alpha into cos square beta. Cross multiply பண்ணிருக்கோம். Okay, so I rewrite cos power 4 alpha as 1 minus sin square alpha the whole square. That is cos power 4 alpha cos square alpha the whole square னு எழுதியிருக்கோம். Cos square alpha 1 minus sin square alpha the whole square into sin square beta equal to sin square beta minus sin square alpha. Similarly, cos square beta is equal to 1 minus sin square beta. Because what we have to prove, in that identity only sin is there, no cos. So, we are changing all the cosine into sine. Okay, using this identity. Now, 1 minus sin square alpha, the whole square, the expansion. So, 1 minus sin square alpha, the whole square can be written like this. A plus a minus b, the whole square. In that form, we can expand that, and sin square beta is equal to sin square beta. Now, we are multiplying this 2. So, first you have to multiply it with 1 and then with sin square. So, 1 into sin square beta minus 1 into sin power 4 alpha minus sin square beta into sin square beta. So, it is sin power 4 beta. Minus into minus, it is plus sin power 4 alpha into sin square beta. Okay. Now, again, you have to multiply the sin square beta inside. So, 1 into sin square beta. Sin power 4 alpha into sin square beta. Minus 2 sin square alpha sin square beta. Equal to in the opposite side la adhe terms. Now, we can cancel the like terms. Sin square beta into sin square beta. Sin power 4 alpha sin square beta. Similarly, sin power 4 alpha sin square beta. We have cancelled it. And the remaining term is minus 2 sin square alpha sin square beta is equal to here minus sin power 4 alpha minus sin power 4 beta. So, negative into minus minus minus. All minus we can cancel and change into positive. So, sin power 4 alpha plus sin power 4 beta is equal to 2 sin square alpha sin square beta. That's what we have to prove. Second part. To prove the second part of the fifth problem, I'll take the first equation. The first result we have got. So, sin power 4 alpha plus sin power 4 beta equal to 2 sin square alpha sin square beta. We have taken it, and so we can bring this term to the opposite side, to the left side. So, sin power 4 alpha plus sin power 4 beta minus 2 sin square alpha sin square beta is equal to 0. So, it is in the form a minus b the whole square, a square plus b square minus 2ab. So, sin square alpha minus sin square beta the whole square is equal to 0. If the whole square is equal to 0, then this term should be equal to 0. That is sin square alpha minus sin square beta equal to 0. That implies sin square alpha is equal to sin square beta. Now, we'll subtract 1 on both sides. You get 1 minus sin square alpha is equal to 1 minus sin square beta. That implies cos square alpha is equal to cos square beta. ஏன் இப்படி பண்றோம் 1 minus போடுறோம்னா அது சைனை in terms of cos change பண்றதுக்கு. Okay. So, cos square alpha is equal to cos square beta. That's our result 1. Now, what we have to prove? Cos power 4 beta divided by cos square alpha plus sin power 4 beta divided by sin square alpha equal to 1. That's what we have taken here. Cos power 4 beta divided by cos square alpha plus sin power 4 beta by sin square alpha is equal to cos power 4 beta can be written as cos square beta into cos square beta plus sin power 4 beta can be written as sin square alpha into sin square alpha. In the denominator cos square alpha and sin square alpha. As cos square alpha is equal to cos square beta, one of the term will get cancelled. So, cos square beta plus sin square alpha. Now, I write this cos square beta as cos square alpha because in this equation we have proved that both are equal. So, cos square alpha plus sin square alpha, and that is equal to 1. That's what we have to prove. This expression is equal to 1. That is our second result.